Okay, so we wrapped up the electrostatics and physics and chemistry review. Um, and again, that was just review and sort of a precursor to what's coming. I want to make it clear that we're not going to be analyzing circuits at the particle level. We're not going to be looking at regions of charge and electrons moving around the same way that you would have or that you would in physics. Instead, DC circuit analysis and really basic circuit theory abstracts away all those details. That's what's going on in the background. That really is what's happening. But we think of these circuits in terms of voltage, current, and resistance because we can, and because this model for circuits has been developed and is very, very, very good and very accurate. And so it's sufficient to abstract away the details and think about circuits in terms of these three quantities. And so I'm going to go ahead and move on to this little graphic. It does look a little silly, but it's commonly used to sort of describe the three quantities that define DC circuits. In this case, they're using ohm, amp, and volt, which are the units rather than the actual names. So voltage is volts, current is amps, and resistance is ohms. But I'm going to describe just a little bit about what each of these three things mean in the context of circuits. And so previously we've seen, there's some force that's pushing these electrons around. I was talking about the electric field and what it is that's actually pushing the electrons. That's what's known as the voltage. And so you've probably all heard of voltage before. If you have a 9-volt battery, that's just a measure of how strongly that battery will push charges through a circuit. There are other names for voltage, such as the electromotive force. I don't think that name is super common. You won't hear it all that often, but just the fact that it has the word force in it is pretty intuitive to me because, again, it's the force that pushes the charges through the circuit. And that's what we see in the diagram here. Our little volt guy here is pushing the charge or the amps through the circuit, the current through the circuit, which I'll talk about the current next. One other name for voltage is the electric potential. You'll hear that one far more frequently than you will hear electromotive force, but voltage and potential are used pretty interchangeably. Somebody might say, oh, what's the voltage at that point in the circuit? Or someone else might say, oh, what's the potential at that point in the circuit? And they mean the exact same thing. And again, I wrote it up top, but I'll just write it again. It's measured in volts, or more briefly, the letter V for voltage. And so current, the next one, current is the next quantity that we care about. Current is a measure of how much charge is flowing, how much charge is flowing per unit time. So if I have, let's just say I have 1 coulomb of charge flowing through some cross-section of wire in 1 second, that would be 1 amp of current. It's amps, which is really amperes, shortened to amps. Ampere is somebody's name. And then it's also just the letter A when we write it out in shorthand. And so the voltage is the force that pushes the charges through the circuit. Current is a measure of how much charge flows through some portion of the circuit per unit time. And lastly, we have resistance, which basically tells us how well does some material, allow charges to flow. Or really what resistance tells us is how poorly, I guess you could write how well or how poorly poorly does some material allow charges to flow? Really what poorly would be the resistance, and how well does some material allow charges to flow would be the conductance. These things are inversely related. The resistance is 1 over the conductance. The conductance is 1 over the resistance. You've heard of a conductor before. You've heard of things that are good conductors of heat, things that are good conductors of electricity. If something is a good conductor, that means that it's very conductive. That means it's not very resistive. And if something is very resistive, that means it's not very conductive. So they're inversely related. I'm going to wrap this video up here. Just wanted to give a little overview of this graphic, and then in the slides to follow, I'm going to go a little bit deeper into current, voltage, and resistance using some of my own figures.